Good morning, you guys. This is video lesson number 3, where I introduce dimensional analysis. This will actually be a very short video because I'll be spending a lot of time today in class demonstrating this process with you. So the purpose of this short video is just to show you once again the slides that I talked about in class and tell you how to look up the answers and check your formatting. I'm going to switch to, I'll share my screen and switch to my slides. All right, here we go. Introduction to Dimensional Analysis. What I'm going to be working with today includes the class packet, the homework packet, the textbook, and the calculator. You have to have a calculator out today. I fully realize dimensional analysis is a brand new idea. We can do this. I'll teach you why it's so valuable in science. But before we start, I want to show you on the class packet, page 1, this concept map keeps you posted as to where we are in the chapter. We have done all of this on the summer assignment with sig figs and calculations. Now we're starting this second part of the chapter where we use dimensional analysis. Yikes. There are specific formatting expectations for both dimensional analysis and percent error. So I want you to be aware of how to show me your work. I will be diligent in training you with good habits as you produce these solutions. Notice this is on page 2 of the class packet. I will be talking about these equalities that I turn into conversion factors to do a dimensional analysis problem. Notice how I always have number and unit, and the answer is written in correct sig figs. You might ask yourself, why does this answer have only one sig fig in it? That's a good question, and you should know. When you do percent error, there is also a correct formatting. First you write the equation, then you substitute in the numbers with units. Don't forget the times 100. Here is my yellow oval where I highly recommend you do the subtraction so that you see how many sig figs you end up with after the subtraction. Then you calculate the final division for the percent error. Division n multiplied by 100. What SI units do you have to know? That's Systems International. You need to know these blue arrows for the prefixes for the metric units. This is a document that's posted in Schoology Chapter 2. Please know that the mega, kilo, hecto, deca, deci, centa, milli, micro, nano, pico. You need to know what those prefixes mean so that we use them in dimensional analysis. You also need to know the base units, but not all 7 of them. You need to know 5 of the 7 base units. So here's the introduction to dimensional analysis. I won't be going over a lot here in this video because I spent a lot of time in class with you on this introduction. But I point out that when you want to do the math of converting one number to another, with this unit into another unit, for example, 40 miles per hour into how many centimeters per second is that? You use dimensional analysis. I will always give you the equalities that are not commonly known. Also, for any quiz or test, you may use the back side of your class packet If you look at the back side of your class packet at page 20, there is a list of conversion factors here. You may have this out for any test or quiz and use that sheet only. But you'll notice that I'm not giving you the metric conversions. You need to know how many millimeters are in a meter, how many centimeters are in a meter, how many meters are in a kilometer, etc. So you have to choose the equality that helps you convert miles into centimeters and hours into seconds. These these equalities are then set up into conversion factors and dimensional analysis is done. You may look up the solutions to this problem on page 12 in Schoology. I worked this very slowly in class today. Same with problem 2 and problem 3. These are probably a little difficult for you until you get more used to dimensional analysis. Go back to the homework that you need to do tonight, Wednesday night, and that is just the start of dimensional analysis. But I did show you practice problem 2 and 3 to see where we go with this style of solving math problems. On page 9 in your class packet, I'm showing you how important it is to format your answer correctly. You get more points on a test question for clearly showing me what you're doing than for the answer itself. So know that I am very emphatic about formatting dimensional analysis. It's like learning to play the piano. You've got to get your fingertips up and your hands level to be able to accomplish the skills of being a good piano player. I am teaching you habits now for dimensional analysis. There are two ways you can solve problems as far as a format in math. One is with an equation, where you write the equation down and you substitute in numbers and solve for a variable. We will be doing that in chemistry. We will also be doing dimensional analysis. So here is a problem that you can read, and I did take the time to show that when you do method 1, it's solving a math problem with equations, substituting in numbers. This is what you do. First, you write the equation. Then you isolate the desired variable. Personally, I don't always isolate the variable. I can solve for it just seeing it in the equation. Then you substitute in the numbers with units. Can I be more emphatic? Units accompany every number. There are no naked numbers in my class. Now your calculator will give you a number, but it will be a lie as far as how many sig figs are in it. You need to only write down the answer. Only write down the answer with the correct sig figs after looking at the measurements that were in your calculation. Here you have one measurement with 3 sig figs, one measurement with 3 sig figs. Since you're dividing, you count sig figs. You should put 3 sig figs in your answer, not the 4 that your calculator says. Here's method 2 for solving math problems, dimensional analysis. You have to identify what is given, what you want to find, recognize the equalities that you need to do the dimensional analysis, and then set up the problem in this format. Density might be an awkward example to show you with dimensional analysis, but I'll do many others with you in class. So to summarize this lesson, by the end of today with the homework, you should be able to know, can you recognize SI units? There are specific SI conversion factors you need to know. Common metric conversion units. Do you know what an equality is? And I remind you that you can always use, it's called SI units and conversion factors on page 20 in your class package. You transform any equality into two conversion factors. Can you solve a problem actually both of these ways, with an equation and with dimensional analysis? We are just starting this today. We will do more dimensional analysis for the next several days. But heads up, we'll also be starting a new lab. So make sure you are managing these various threads of IBSL chemistry and working towards holding them all together. I just wanted to show you that in chemistry, we're not really so interested in converting inches into miles. This is what our dimensional analysis will eventually look like in chemistry. Here you have a chemical equation. Magnesium nitrate plus potassium hydroxide gives you magnesium hydroxide and potassium nitrate. You'll be able to do that in another month or two. I can solve for how many grams of magnesium hydroxide are formed when you start with 15 mils of potassium hydroxide. I can do that math in chemistry by using dimensional analysis. I take the 15 mils and I convert them into liters. I convert liters of a solution into moles of KOH. I convert moles of KOH into moles of magnesium hydroxide. I convert moles of magnesium hydroxide into grams of magnesium hydroxide. And this dimensional analysis lets me solve for, I will have 0.20 grams of magnesium hydroxide from this chemical reaction. So that's where we're going, but first I'll teach you the skills of dimensional analysis. Thank you for being with me today. Stay with me. Let me know what help you need. Ask 3 before me. Goodbye. Goodbye, you guys. See you in class today.